We'll proceed in calculus theorem. Okay, so mind-blowing discussion that we are continuing in calculus theorem in a way that promoting the single variable to multiple variable. This is something that is the only thing in machine learning, artificial intelligence, and whatsoever. The difference in single variable in multiple variable. That difference, if someone understand, if I'm not serious about it, if I'm saying something that is not true, then go and see the book, see the variance. If someone try to calculate the variance among the two different pattern, then you have to calculate a mean value. Consider I have a set of pattern, set of inputs. I have another set of inputs. I have two set of data. I have two set of data, and then I am trying to find covariance. Or I have one set of data, and I am trying to find variance. I have three set of data, four set of data, or I have one set. I'll try again. Okay, there is something that I have one set of data. I have one set of data, and I'm trying to find a variance. Variance means how much the data is away, how much the data is away from the mean. That is called variance. Make sense? How much data is spread in the distribution. Not understandable. I'll try again. Consider that I have a data that is 1, 2, 3, 4. Consider there is a class of 11 students. In a class, there are 11 students, and among the 11 students, now there was one examination happened in the school, and the class 11 students they secured some marks. Now I'm trying to draw a chart now. I'm trying to draw a chart now that is called probability distribution. And in that chart, this is marks axis. In that chart, consider this is Mark's axis. This is Mark's axis, and this is the probability of the marks. Understandable? Consider this is the Mark's axis. Marks is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Students have got marks only in whole number, not in fraction number. Students have got marks as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I'm asking there are 11 students in the class. There are 11 students in the class. Only 11 students are there in the class. I'm asking everyone to reveal their number in the class. One person is saying 0. Consider everyone is saying marks. One is saying 4, one is saying 5, one is saying 4, one is saying 5, one is saying 4, one is saying 5. Out of 11 students in the class, 5 are saying that they have got 4 marks, and 6 are saying that they have got 5 marks. If I try to draw a chart, consider this is a marks 4 and this is marks 5. Against 4 there will be a vertical called what is the probability of getting 4 marks. That is nothing but that is 5 students have got 4 marks and 6 students have got 5 marks. Okay, so 4 marks, if I draw a vertical, the vertical height will be 5 by 11. Out of 11 students, 5 students, they have got the 4 marks. This is 4 marks. This is 5 marks. Against 5 marks, there will be a vertical, and height of the vertical will be 6 by 11. One height will be 5 by 11. One height will be 6 by 11. Means out of 11 students, 6 students have got 5 marks. Out of 11 students, 5 students have got 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 4 marks. So probability of getting 4 is 5 by 11. 5 students out of 11 students, they have got 4 marks. Probability distribution, if I say for the 5 marks, then out of 6 students out of 11 has got this 5 marks. This is called probability distribution. Means out of 0 to 10, all the students are in the range of 4 to 5 marks only. That's it. Others are full empty. If I keep changing this distribution, then I am changing probability distribution. If I take instead of 11 students, if I say class has 300 students, then against each marks, I have to see what is the probability. Then I see this probability is matching to which kind of probability distribution. Is it a Gaussian distribution? It is a other distribution, gamma, beta, so many distribution are there, exponential distribution. So many, it is matching to which kind of distribution. Now the consider that all, if I'm asking in a class that how many marks you have got, every student, one is saying 0, one is saying 1, one is saying 2, one, all 11 students have got distinct marks. 0, 1, 2, 3, 4. Now there are two situations now. In one situation, students have got marks 4 and 5. All students have got marks 4 or 5. Or all students have got marks 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are two distributions I am talking. If I talk about the mean of distribution, what is the mean of distribution? The mean, the first distribution mean, if I say, what is the mean value of the marks? The mean value of the marks is 5 students have got 4 marks. 5 into 4 makes sense. Plus 6 students have got 5 marks. 6 into 5. 30 plus 20, 50. 50 by 11 is the mean marks. 50 by 11 is the mean mark, not 4.5. 4 and then 5 in between 4.5. 4 into 5, 20. 5 into 6, 30. 50 by 11, that is the mean mark that a student has got. If it is a continuous distribution, people also write x fx integration from lower limit to higher limit. If it is a discrete, then people write it x into fx summation. Fx is the probability distribution, whatsoever it is. Now, if I say where is the mean of the class, the mean of the class is 50 by 11. Now, from 50 by 11, then I will ask what is the variance of the class mark? Variance means from the mean, how much it is distributed, how far the marks are distributed if I go left side and right side. Then from 50 by 11, I have to go up till 4. 50 by 11, I have to go up till 5 only. Means all marks are concentrated in this region only. So variance is less. It very less if I go forward. It is the marks is concentrated around the mean only. Consider that in a class I have a students, and a student is from 0, 1, they have got marks 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 students have got 11 distinct marks. Now tell me what is the average of the mark, that is called mean value of the mark. Then someone has to add 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Add this by 11. How much it will come? 10 into 11 by 11. 10, I think so. Up. How much will be addition? How much will be addition from 0 to 10? If it is n, then n into n plus 1 by 2 by 2. 10 into 11 by 2, that will come as 55. 55 by 11, 5. 5 is the average. Now I'll say in earlier case the average or mean value was 50 by 11. Now the mean value is 55 by 11, that is 5. Now I can say that when we have 0, 1, 2, 3, 4, 5, at 5, oh, this is 5, this is 4, this is 5. 5 is the mean value. Now if I say, now you tell me, if all students have got marks as 4 and 5, 5 students have got marks as 4 and 6 students have got marks as 5, then mean is coming as 50 by 11. 50 by 11 will come around 4.6, I think so, 4.6. Okay, if all students have got distinct mark 0, 1, 2, 3, 4 up to 10, then what is the mean value? Mean value is 5. 55 by 11. Then what is difference between these two? Mean value is same. Okay, mean value is same, then there is no difference is there. There is other terminology that comes into the picture called variance. If I take the mean value, then how far the distribution goes along. If I take mean value, how far the distribution goes along. In the second case, the distribution goes from mean value up till 0. and mean value up till 10. So distribution along left and right side, the distribution is vast. Distribution is vast. Means variance is vast. It varies till high extent. So variance is high. How to calculate variance? Then how to calculate mean? We understood how to calculate. How to calculate variance? Then to calculate the variance, we have to take all x value, x equal to 0, x equal to 1, x equal to 2, x equal to 3, up to x equal to 10. With each x you subtract with mean value, x minus mean value. Whatever is it comes, you have to make a square of it. Plus, so I would rather say summation sigma sign, sigma summation x equal to 1, sorry, x equal to 0 to x equal to 10, or I equal to 0 to I equal to 10, sigma sign xi, xi minus mean value whole square divided by n is 11 here, 11 counts are here. Means with each sample I have to subtract with a mean value, square it, and then keep adding for each sample, subtracting with the mean value. This is called variance. But my idea is not to demonstrate the variance and mean, but how simple it is. That is the question now. How simple it is. Okay. Now calculate variance for both the concept. If I had taken all the data, that is 4 and 5, and here all the data is equally distributed between 0 and 1, here variance will be high. First will be 0 minus mean whole square. Okay, that will come as a big number. 1 minus mean whole square, another number. 2 minus mean whole square, another number. In that manner, it will go up to 10 minus mean, that is 5.5 whole square. Okay, add all the stuff and divide by 11. It will be quite big number. If I take in the first case, where all data is at x equal to 4 and 5, then from left side, if I say there is no data at all, it will enter only at 4. 4 minus 4 minus mean, that will be very less value, whole square, plus 5 minus mean, that will be again very less value, whole square. That's it. You have to add these two divided by 11, because there are 11 entity here. More or less variance will come very less. These are called pillar in any probability distribution. And any distribution may have so many characteristics, but it will be defined only by few parameters. It will be defined only by few parameters. This is called pillar. This is called pillar. How I can pick this up? This is a this consider this is a kind of this is a thick stick. It is a thick stick. I want to carry this. Now I'll carry this. See how much area is involved from my hand. I can carry this, or I can carry this, or I can carry this. Full hand is going. Someone is very clever. Then what he is doing is he's carrying like this. See the finger, and then see, on one finger he is carrying like this. Make sense? Okay. So someone, if I ask someone, can you consider this is very highly, it carry very high weight. Suppose it carry 100 kilogram, consider 100 kilogram, and then someone has to hold like this. How much energy he is pushing like this? How much area he is consuming? Okay, someone is very clever, and then he did like this on one point, just one point. He is holding it. What it means, to kind of carry the full information, you need this big data structure. If this is the information rod, then to carry the information, you need this big data structure. But if someone is carrying on a single finger, means you need only this much data structure to carry the full information. And that is actually that is the concept of vector or variance or mean. Full data I have in the class, I can just jumble the full data only with two parameter, mean and variance, where it is centered and how much it is spread across. That's it. Okay, anyway, this is the one query. Another query is consider that there are four parameters. Now every student has marks attached to him. If I ask a student that can you please stand up and tell me what the marks you have you have kind of got in the class in the examination. Now 11 students they are revealing 11 marks. Maybe some student may have the coinciding marks. Now consider that the characteristic of a student is more than an marks. If a marks is the characteristic of a, I am a student and then I am standing in the class and I have many characteristics. One characteristic is the marks. I believe I have given this example. Other characteristic is my height. Other characteristic is how big my mustache and beard is, how big my hair is. Another characteristic is what dress I am wearing. Another characteristic is maybe other. Now I am carrying 10 different characteristics. Make sense? Now tell me what is the variance now? Every student has 10 characteristics. How what is the variance now? Now instead of variance, because variance will be per characteristic. If I say full place, can you give me one variance scenario? Height will have different variance, it will have different mean, different variance. Then the kind of age of the student will be, if I consider the month wise, then they will have different variance. From the mean, they will have different distribution, left and right. Marks is different distribution. Altogether, if I say, can you tell me what is the variance? Variance among the different characteristics of the student. Then you have to draw a big matrix, and in matrix, it will be if there are 10 characteristics of a student, then there will be 10 by 10 matrix will be there, and that is called covariance matrix. Covariance matrix is actually variance of the class. Earlier, if each student has one character, that is the marks, otherwise they don't have any other character to reveal. Only one character as marks, then variance calculation is a single number. Variance, that is nothing but you iterate student by student. First you calculate the mean of the number of the marks, then you iterate student by student, and that student marks minus mean whole square plus another student marks minus mean whole square plus another student marks minus mean whole square. Okay, if I calculate doing like this, divide by n, how many students are there, that is called variance. If you take a square root, that is called a standard deviation. Okay, if I take a standard deviation also, this is how it is. Now each student has 10 characteristics: his age, his height. Someone can take color complexion also, from dark to white, where the skin color is in between, how big the mustache is, how big the beard is, how big the hair is, what dress he is wearing, he is a girl or he is a boy, oh sorry, she is a girl or he is a boy, like so, so many characteristics. Now I'm saying, can you tell me the variance in the class? Then 10 different characteristics are there. Okay, for 10 different characteristics, someone will say, what is there? There are 10 mean. If there are 10 characteristics are there, then there are 10 mean. What is the mean of the height? What is the mean of the age? What is the mean of the mark secured? Something like that. But if I talk about variance, it will form 10 by 10 matrix, and this is the variance of the class. See the complexity. If there is a one characteristic, then variance is in one number. If there is a 10 characteristic, then variance is 10 by 10 matrix, that is 100 in number. Means if I go multivariable case, then things start becoming very complex. Things start becoming very complex. We will present a paper on it. Okay, in the scenario of variance for the multi-feature item. Like consider I take three class of roses. Okay, I identify there are three class of rows. Three class of rows means one rose is big, it has different color, and then it's the flower petal and those things comes. Their size is different. There are many feature in a rose that I am identifying that it is this feature I can consider the normal height of the plant. If adequate manure and water is given, then what is the normal height of the plant? how big its thorn is, because rose will have thorn also, how big its leaf is, what is the color of the leaf. So many characteristics I will draw against each rose type. Three rose types are there. Consider three rose type of there. With three rose type, I have sample data against one rose type, one rose class. I took 50 sample. Okay, 53 I went with the same rose class, and then I measured all the characteristics. Then I went for the other rose type, and then I went to 50 different plant, and then I measured the characteristic. For the third type of rose, I went to 50 different plants, I measured the characteristic. Make sense? Okay. Now for the first characteristic, first 50 in one type, I am generating a probability distribution model. Consider this is a Gaussian model. If this is a Gaussian model, then it will have a mean value, it will have a variance. Variance will be very big because there are 10 characteristics per type. Then mean. For other type, again variance and mean, and third type also variance and mean. With that variance and mean, I am drawing a Gaussian distribution. Gaussian distribution is 1 by a square root of 2 pi into 1 by standard deviation, or a square root of variance, e to the power minus 1 by 2 x minus mean by variance. This is what I remember. I have to check always. I say this is what I remember. This is called Gaussian distribution. Gaussian distribution, I have to, when I calculate Gaussian distribution for any data, then I have to fix mean and variance. From all the 50 data in a particular rows type, I have to generate mean and variance. And then I have to come up with this formula where only one variable is leaving, that is x. Make sense? Now, if that is the case, then if I go again with all the 50 data, all the 50 data for a particular rows type, and if I start filling the x one by one, the probability that it will generate will be high. Means for all the set of 50x against this probability distribution, or sometime it is called model in machine learning, the probability will be high. Now I take a random. Now the question is, for that, with that I am preparing three models. Understand? I'm preparing three Gaussian probability distribution with different mean and variance, different mean and variance, different mean and variance. One distribution talk about one rows type. Now when it is done, now these formula are these formula are with three independent components. One is x, one is mean, and one is variance. Anyone can check the Gaussian distribution. One is x, one is mean, and one is variance or a standard deviation. That is the three independent component in Gaussian model. I am generating three Gaussian model with three rows type. Okay, they are fed and it is trained. Trained means mean and variance I have said differently looking at their feature. The question is arising that someone is bringing one rose type and he is asking me, can you guess what kind of rose it is? Now, if I take out all 10 features of that rose, what I'm looking, and then if I feed in these three distribution, one distribution will give high probability against that x. Okay, but while calculating, we have to calculate the variance and mean, and that will be pretty complex if I go in the feature wise. So multivariable things makes the difference. If someone is understanding how to create variance, how to create, what is the complexity. If I go little bit down the scene, what is the complexity in the variance or covariance or something like that. If I have three set of rows, consider I have three set of roses. If I have three set of roses, three type of roses, with three type of roses, one rose I will take out 10 different features, another rows 10 different features, another row 10 different features. With those features, I will estimate mean and variance, and then I will draw a probability Gaussian distribution for all these three rows type. Now I'm taking one arbitrary rows and then I'm trying to find it belongs to which rows. I'm asking to anyone, any human. Okay, I have kept 50 rows, 50 rows, 50 rows, 50 rows in three bundles. Okay, along with their tree. I have taken one person into three gardens. Three gardens. One garden is with one type of rose, one garden with another type of rose, one garden is with another type of rose. Okay, he is not a mathematician that he is going to measure the feature. Okay, one type of rose, then he will measure what is the flower length, width, every petal or sepal, whatever it is, and then what is the height. Many things he will measure of all the plants because all should be similar. Then he feeds to one mathematical formula, and that is called probability distribution. Similar, he will go to another garden, he will go to another garden. Three mathematical formula he will generate, and where the independent component will be three again. For each, there will be three independent components. X, that is the input data, mean and variance. And then now some children is now I am taking that I'm now consider that garden belongs to someone else, and I am the person who is the classifier. He showed me all three gardens. These are the rose type 1, rose type 2, rose type 3. Then he is taking me to another garden, now fourth garden. Now he is telling me, can you tell me the whatever rose you are seeing, it belongs to garden type 1, type 2, or type 3. There are only three types. This is the fourth garden, but this garden belongs to which among them? Which type of rose among them? Then what a human would do? Human would try to generate a correlation. If I see from the eye, or then I will for the consider fourth garden has only one rose plant. I believe it is problem is simple now. The fourth garden has only one rose plant. When I open my eye, then immediately I will try to match that rose with all three gardens where it is matching the best. Then I'll say it is garden number two. Then someone will say, how you said that it is garden number two? This rose belongs to garden number two. How you said? See, it has, if I see the sepal or petal, these are the properties of a flower. This big it is and this wide it is, the way iris data said that is a famous. See, the plant height is this. If I take the plant height by plant width, it is like this. The leaf color is this, flower color is this color is that color is this, or something like that. Consider that the first three garden, one at one place rose is completely red, another place maximum of the rose, another the rose is pink, and third rose is yellow. Yellow, pink, and red. Makes sense? Now I am showing him a rose plant that is yellow in color, and tell me which family it belongs. But he is pointing to second family, that is pink, even though the color is yellow. Because then I will say, then I will ask him how you estimated like that. Color is completely mismatching. Color is mismatching. Okay, if I take the other width and area, other width or something like that, then it is matching to. Okay, his answer is the fourth garden plant is matching the second garden pink color. Consider like that. But if I measure all 10 feature of that plant, none of the feature is exact match to the second garden. But still he is saying it belongs to second garden family. If 10 feature, that is the height, width, leaf color, everything I am measuring, one or other feature is matching other two. What he is saying it did. Consider it is type A, type B, type C. A is red in color, B is pink in color, and C is in yellow in color. Fourth garden, there is one rose plant. If I calculate all 10 features either they match to A or B exactly, something like that. Still, he is saying it belongs to B. How come he is saying? This proves that all 10 feature what he is saying in one go, he is trying to correlate through his mind. One go. In one go, all 10 features, he is trying to correlate through his mind in one go. He is not going feature by feature. Okay, what is the height? This much is the height. Now he is checking A, B, C. Oh, it belongs to A. Tick mark A. What is the color of the leaf? This is the color. Oh, it is like C, the tick mark C. What is the color of flower? The color of flower is yellow. Then type C, tick mark. Then he will read. Type A, type C, type A, type C, type A, type C. Now out of 10, 5 is 6 is belongs to type A and 4 belongs to type C. This proves that The flower is of type A. The answer is type B, even though none of the characteristics is exactly matching. But if I take the relationship of all 10 characteristics together, there the similarity between all the characteristics, if I take only two characteristics, consider, if I take only two characteristics, then how much these two characteristics are related to each other in the fourth, in the fourth garden, how much these two characteristics are related to each other, and that two characteristic relation that I will try to generate both of for the ABC, and wherever relationship is matching, it belongs to that. Now, how these 10 characteristics are matching, how 10 characteristics would match. Consider characteristics are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I am now renaming the characteristic as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the characteristics. Now tell me, what is the correlation I can think about this characteristic? How 1 and 2 are related to each other? How 1 and 3 are related to each other? How 1 and 4 are related to each other? How 1 and 5 are related to each other? How one first characteristic is related to all 9 characteristics? Now the second one. How second one is related to third one, and so on. This is the one way. Now other way is first 3 3 you try to match the characteristic. Then 4 4, how much neatly you are making a mesh relationship, that is the best estimation you can make, and that is the fight that is going on. If people would have searched, seen the chat gpt and those kind of things on the internet, this is the place where you see the different results. Okay, based upon the features they try to create the model, and the relationship between the feature, the way they generate, that is different. Sometime one you will get best result what you are looking, sometime you will get at other best result what you are looking, because based upon your query, the way they will make the inter-feature relationship, that is different. Anyway, we will proceed now. This is called multivariable thing. If it is one, then there is no other way. It has to be only one. If I have fourth garden and I have taken only one characteristic into the picture to identify the class of the flower, and that color is yellow, then I will say it belongs to type C. Okay, because only one character I have taken, then someone will say, if you take more correct, then more chance that you will identify the exact thing true. More characters you will take into picture, then more chance that you will identify exact, but more mathematical processing and how you are interrelating each other, and those things make sense. I believe people understand what is the concept behind the multivariable case. How it is. Single variable only you make a tick mark. Color match, okay, that is belongs to it. But if you start going from 2, 3, 4 onward, then inter relationship, how mesh you make, that start making difference. And that how it is considered as inter property, inter feature relationship. This calculation is maximum with the neural network, deep learning, where we have maximum way I can calculate the cross mesh kind of the relationship among the feature. That's how the neural network is considered as the best network. Anyway, but there are others also. Anyway, we will talk more on it, but before that, multivariable calculus is required. Now, for the multivariable calculus, we are in discussion of calculating the gradient vector. Gradient vector. Gradient vector means if I have x-axis, gradient vector means if I have, consider I have x-axis, this is x-axis, then this is y-axis. If this is x-axis, then this is y-axis. If this is x-axis and this is y-axis, then there is a graph like this, that is called fx. If there is a graph like this, that is called fx, function over x. Now, if this is origin and this is x, if this is origin and this is x, if I draw a vertical line, then this height is called function over x. If I move along x-axis, then this height will also change. See, it is going low. It is becoming high, then going low. As I move along x-axis, this fx is changing. Now question is, in the direction of movement along x-axis, how much height is changing at a particular point x if I move 1 unit? Makes sense? If I have a point here called x, and at that point I have a height called fx. If I have a point called x and I have a height called fx, how fx is changing if I move 1 unit from x, then how much difference in y I see? At x, height is fx. If I move 1 unit, then height is fx plus 1. How much change I see in the height if I have moved 1 unit from point x? That is called dfx by dx. Or if I have x and if I move delta x and then I calculate the height, then how much change in the height I see if I move delta x? That is that is fx plus delta x minus fx by delta x. That is same as how much fx has changed per unit. If I divide by delta x means per unit. How much fx has changed per unit? Per unit at point x. If I move x, then how much fx is changed? Dfx by dx. What is the direction? No one bothers about the direction. If you see single variable case, no one bothers about the direction. Only answer is how much fx is changing per unit change in x-axis is dfx by dx. In what direction? Dfx x you are changing, but in what direction? Because there is only one direction. There is only one direction. There are no two directions. And people can write it as dfx by dx I direction I vector, or d by dx I vector bracket close outside fx. This is called gradient vector. D by dx I vector is called gradient vector. Means things will change along I axis per unit change in x axis. That is d by dx I vector. Okay, then we calculated the same analogy with the dual variable case. Now consider dual variable case. What is dual variable case? If I take single variable case, then it is guaranteed that whatever 2 point I am taking x and x plus delta x, these 2 points if I connect, then they will pass through origin, guaranteed. That's why single variable case has no complexity at all. But if I take dual variable, okay, consider I am taking dual variable case. This is dual variable case. If this is x-axis, then this is y-axis. If this is x-axis, then this is y-axis. Now, on this is xy plane. On top of xy plane, I have a surface like this. This is a two-dimensional surface is kept on xy plane. Now I take any point here called A and another point called B. If I connect A and B, it will not pass through the origin. Origin is here. I take any point A and any point B. Consider like this. Consider the gap between A and B is delta A. This is the difference between single and if I consider x-axis like this, then any 2 point if I take, certainly it will pass through origin, guaranteed. But if I take two dimension onward, if I take any 2 point, if I connect through a line, there is no warranty that it will pass through origin. It is exactly different. Consider what if I take 2 points on x-axis, then what is the gap between 2 points? Delta x. If this is origin, this is x, then this is x plus delta x. X plus delta x. Gap is delta x. If I say that if I have a point A here and point B here, what is the gap between these two? Consider gap is delta x. Wrong. Gap is delta A, delta area. Any 2 point in xy plane, they will be different by area, not by the line. This is the first concept we are bringing in. Okay, and with that we will derive all the calculations. If this point is x1 y1 and this point is x2 y2, then distance between x1 y1 and x2 y2 is x2 minus x1. That is the gap if I take x axis, and y2 minus y1. That is the gap I take in y-axis. I have to multiply these two, x2 minus x1 into y2 minus y1. That is the area delta A. The gap between any 2 points in on xy plane is delta A, not delta length, delta A. Delta A is the gap between these 2 points. Now question is, if I take any point A and any point B, and A if I draw a vertical, from B if I draw a vertical, and these two vertical, they go up and they hit this 3D surface. This is A point vertical and this is B point vertical. Now you tell me at point A and point B, if their gap is very less delta A, point A and point B, the between gap on xy plane is delta A, the minimal gap between this delta A. Now tell me that if I move from A to B, how much the height change I am seeing per unit change in the x-axis. Okay, what I am trying to say, or take any point on xy plane at x comma y. Then take another point on xy plane at x plus delta x comma y plus delta y. 2 points. X comma y, another point is x plus delta x comma y plus delta y. In that manner, you take up and then see the vertical. Then one is fx comma y, another is fx plus delta x comma y plus delta y. How much vertical it has changed per unit change along the xy plane. If I make delta x into delta y area change in xy plane, then in vertical I can see fx plus delta x comma y plus delta y minus fxy. This much height change I see. If that is the case, then what will be per unit area? Then you have to divide by delta x delta y. Means fx plus delta x comma y plus delta y minus fxy by delta x delta y is the height change per unit area change. The exact correspondence between univariable and multiple variable is like this. In univariable, if I move delta x, then how much I have moved vertical, means how much vertical is moved per unit. If I move delta x, then how much vertical change I see. If I divide, it will say how much vertical has changed per unit change. That is dfx by dx I vector. In two dimension, if I say if I moved 1 unit area on xy plane, then how much vertical has changed. Do one thing, in xy plane move delta x delta y, then see how much it has changed and divide by it. It will become fx plus delta x comma y plus delta y minus fxy by delta x delta y, and that will become dfxy by dx plus dfxy by dy. Please watch our previous video. One thing I am missing that I have started discussion, that is called pillar. In how much, if I want to carry anything, then I can carry with few parameter only. And there I had talked about Gaussian parameter. That was mean, and through mean and variance only I can describe the full data only sitting upon two pillars. Here also pillar comes into the picture, where full data will be based upon only two pillars, and that is I vector and j vector if it dual dimension, I vector if it is single dimension, whatsoever it is. If I talk dual variable and if I trying to see how much height is varying per unit area change, the answer will come as dfx by dx I vector plus dfx by dy j vector. How it is? Please watch our previous two videos. Now the analogous to dfx by dx I vector is same as dfx by dx I plus dfx by dy j. Okay, or I can say d by dx I vector plus d by dy j vector bracket close into fxy. This d by dxi plus d by dyj is called gradient vector. How much things are changing along I vector plus how much things are changing along j vector. If you add these two, it is called gradient vector. This gradient vector, it deals with everything in two dimensions. Now, I can happily say, now someone will ask, can you tell me how much is your gradient vector? Gradient vector at on xy plane if I take a point 2 comma 3. Consider a case like this. Consider this is xy plane. On xy plane above it, I have a surface like this. Okay. Now I have taken a point on the xy plane at 2 comma 3. If I draw a vertical from that plane, then this vertical will go up and hit this point. Now question is arising at this point, what is the gradient vector? How much things will change? Like in single dimension, it was d by dx. D by dx. Here it is d by dxi vector plus d by dyj vector, bracket close, fxy. Okay, change is d by dxi plus d by dyj fxy. If I know fxy how much it is, then dfxy by dxi vector plus dfxy by dyj vector. If I ask anyone, then can you tell me what is this gradient what you are talking? That is the change in the height per change unit change in area at point 2 comma 3. This is what I want. 2 comma 3. If people remember, in single dimension, if I talk about single dimension, gradient talks about the tangent line. Any gradient talks derivation, differentiation talks about the tangent line. In two-dimensional case, independent variable is x-axis, independent variable is y-axis, xy plane. In xy plane, when I have xy plane, if I have xy plane, there if I'm trying to see how much vertical is changing per unit area change, that will come as dfxy by dxi vector plus dfxy by dyj vector. Consider this fxy, that is the surface, is x square plus y square. Then my question is, can you tell me how much is the change I am seeing at point 2 comma 3? dfx by dx will be 2x, dfx by dy will be 2y. Now I am free to place this number 2 comma 3. Means 2 comma 3 whatever, that the answer will be that much. I vector and j vector right now I can leave it out, because the actual answer is dfx by dx plus dfx by dy. I had placed I and j later. Please watch our previous video. Means if I so I'll try again. I believe I am messing up two things. Now I'll try again. Consider that there is a surface above this xy plane, and the surface equation is x square plus y square. Equation x square plus y square means if I take any point x comma y, and if I draw a vertical, it will hit the surface, and that height is x square plus y square. Now anyone is asking, can you tell me the gradient? Can you tell me the gradient that is available at any point 2 comma 3? Then answer is dfx by dx at x equal to 2, y equal to 3 plus dfx by dy at x equal to 2, y equal to 3. This is called gradient. Gradients means this gradient will be used to calculate tangent surface. If I have a surface like this, consider this is x square plus y square. From 2 comma 3, if I go up and it hits this point, there I can have a tangential surface. But problem is this tangential surface can be in 360 degree. If I take any point on x, any point on a surface, and if I talk about a tangential surface at that point, tangential surface can be generated through gradient in single dimension also. This tangential surface will be in 360 degree. That is the problem. Which one you want? Anyone would ask. But if I talk about the single, see the how much complex it is two dimension. If I talk about the single, if this is x-axis and this is the single dimension, any point if I ask, can you tell me what is the tangential line? Here it will be 10. The tangential line will be only one. It will not rotate in this manner. Only one will be there, and that is easy to find, dfx by dx. But here dfx by dx I plus dfx by dj, this will give tangential surface equation in 360 degree. That is the problem, bigger problem here. Then someone will say, what you want? What you want? Then I want at 2 comma 3, but you calculated for 2 comma 3. Yeah, dfx by dx, whatever it comes, you replace all xy as 2 comma 3 plus dfx by dy, you replace all the xy with 2 comma 3. That is the result. Then which surface I took? That is the question now. So if I say on this surface there is one, this point is there, if I draw a vertical, it is going to hit xy plane at 2 comma 3. Then at this point the change I see change, the gradient vector, the change I see is dfx by dx, dfx by dy. If I don't add these two, if I talk in vector form only, then dfx by dx, whatever it comes, if equation, it consider equation is x square into y square. Equation is x square into the equation of the surface is x square into y square, or for simplicity x into y. X into y is the equation of surface. Now at any point 2 comma 3, that is the x comma y and the height fxy, 2 comma 3 comma f2 comma 3 is this point. At this point, can you calculate the gradient surface, that is the tangential surface, that will be dfxy by dx, that will dxy by dx will be y, I vector plus dfxy by dy, that will be x, because xy, if I differentiate with y, x will remain. Now first bit is y, at y equal to 3. I believe I should take x square y square, both will be there. Consider it x square y square is fxy, then it will be 2xy square, and here it will be 2yx square. Now 2xy square, I have to feed x with 1, x as 2 and y is 3. And here 2yx square, I have to feed x with 2 and y is 3. Same. Whatever I got, that I plus that j. Okay, this is called, means dfxy by dx will tell me how much things are varying in xz plane. Dfxy by dy is telling me how much things are varying in yz plane. But the question is arising that if I have given the answer, someone will say this is a perfect answer. Knowingly, unknowingly, you have given a perfect answer. What the perfect answer is? The perfect answer is dfxy by dx, I vector plus dfxy by dy j vector, and you calculated this for x equal to 2, y equal to 3, x equal to 2, y equal to 3. Then if this corresponds, these are rough, loose manner I am talking, this may not be very perfect. Then what, but if I take this point and if I say this gradient talks about the tangential surface, which tangential surface you told me, because there will be 360-degree tangential surface. The answer is that this gradient, what we are talking, gradient will always be along a direction, but in x-axis there was no direction, there was a direction. If I talk about the x-axis, consider this is x-axis and there is a line above it. Above this line, if there is a point called x, and if I go up and this is fx, if I calculate dfxy by dx, then whatever gradient I am calculating change in fx per unit change, that is in direction of x-axis, because on x-axis I am moving and then fx is changing. What about if blindly I am saying I am trying to calculate gradient at any point 2 comma 3, then along which line I am changing? That line is line connecting the origin. From 0, if I connect the point 2 comma 3, if from 0 comma 0, if I connect a point 2 comma 3, it makes a straight line. Along this line, if I go up and then if I draw a vertical like this and there is a surface, then the surface will start changing. The surface will start changing separately along the line I am trying to calculate. Makes sense? Consider this is a point called 2 comma 3 and this is origin. I can connect like this. But through 2 comma 3, there are in 360 degree, there are infinite line can cross. If this point is 2 comma 3, through 2 comma 3, there are infinite line can cross through 2 comma 3. One of them is passing through the origin. There can be infinite line. If there are infinite line possible that is passing through 2 comma 3, that's why if I go up on the surface, then there are infinite tangential surface as possible at 2 comma 3. Depends upon we are trying to calculate gradient along which line. Now it is clear now. If I have a point 2 comma 3 on xy plane and point 2 comma 3 on xy plane, if I take, then around it there, if there is a single point here, then around it, if I take a line, then there are infinite, how I can say, if there is a point here 2 comma 3, then there is a line like this, then there are infinite line possible that is passing through common 2 comma 3. Which line I am taking? Because since line are infinite, and if I from 2 comma 3, if I draw a vertical and it is going to hit the surface, and there I am trying to estimate a tangential surface. Tangential surface will vary in 360 degree. Which one I want? Which one I want? Then answer is, if I am calculating at 2 comma 3, knowingly, unknowingly I am calculating the tangential surface that is along point 0 comma 0 to 2 comma 3, knowingly, unknowingly. If that is the case, then how we did? How we will go through? Dfxy by dx at x equal to 2, y equal to 3. Dfxy by dy at x equal to 2, y equal to 3. Okay, this much we have said. We have calculated perfectly. Now someone will jump now. Okay, 100% sure that you have said whatever you have said. It is perfect. Now you tell me for the line that is passing 0 comma 0 and 2 comma 3. This much you have told. But at 2 comma 3, this is the only thing you have. So I'll try again. Now what I am saying, that when I say that the gradient vector in the 2D case is dfxy by dxi vector plus dfxy by dy j vector. Okay. Now how I can make sure that whatever tangential surface I am calculating with this equation, that tangential surface is on xy plane, it is along 0 comma 0 and 2 comma 3. 0 comma 0 and 2 comma 3, that is the question. Means I am trying to find, trying to find the chain that is happening, connecting 0 comma 0, 0 comma 0 and connecting 2 comma 2 comma 3. The answer lies is that how much the hope, will try again, hope. Let's take the two-dimensional case. In two-dimensional case, consider I have a point called 2. It is origin and this is 2. This point is 2. Now I have an equation called x square. If I calculate the gradient will come as 2x. The gradient of x square is 2x. 2x. Now at point 2, the gradient will be 4. The gradient will be 4. Now what is the equation of the tangential line that is passing the point that is x equal to 2, where gradient at x equal to 2 is 4. Otherwise gradient dy by dx is 2x. At x equal to 2 it is 4. The equation of line will be y equal to dy by dx into x. Makes sense? If there is a gradient line, the line will have equation. Make sense? If I say these are my tangent line, everywhere I have a tangent line. Everywhere I have a tangent line. What is the equation of tangent line? Now, what is equation of your curve? Equation of the curve is x square. If the equation of the curve is x square, then at any x, I will calculate the differentiation, that is 2x. Now, if I take x as 2, then this dy by dx is 2 into 2, 4. The equation of tangential line is y equal to dy by dx into x, and that is 4x. At any point x, this is not x square though, this is x square curve. If I take x square curve and if I try to calculate the tangential line equation at point x equal to 2, then tangential line equation will be y equal to dy by dx at x equal to 2 into x, y equal to 4x. Okay. So then we can say that this tangential line, for calculating the tangential line, first we calculated the gradient, and that gradient is in direction of y-axis. Now similar to that, if I say, if this is xy plane, above the xy plane I have a 3D surface, and this is 3D surface. If this is 3D surface, then at any point I can calculate a tangential surface. This is called tangential surface. But problem with this tangential surface is this can be in 360 degree, whereas this is not the case in single dimension. It will be along only one direction. But here, since it is down the line, there is a xy plane, this will be in 360 degree. The question is arising, now which one you want? Okay, which one you, where it is, why it is 360 degree? The reason it is 360 degree is, from here if I take down a straight line, then this straight line will go and meet any point on xy plane. If it meets any point on xy plane, and this point xy plane, I can have a line that will rotate 360 degree. If it rotates 360 degree along any line, I can calculate a tangential surface. Now equation of this tangential surface I am trying to calculate along a line that is connecting origin and x comma y. That is the question. If I have an any so I'm sorry, if there is any arbitrary point on xy plane as a comma b, there is a line that connects origin and a comma b. Along this line, if I calculate a tangential surface on this tangential surface of a 3D surface, flat surface, what will be equation of the tangential surface? Equation of tangential surface will be dfxy by dx into x plus dfxy by dy into y. The way it was in 2D, dfxy by dx into x, that is y equal to dfxy by dx into x, where dfxy by dx is calculated for a particular x. Now here it will be dfxy by dx into x plus dfxy by dy into y, and this value will be called z. Z is nothing but the equation of the tangential surface. Z equal to dfxy by dx into x plus dfxy by dy into y. If I just calculate like this, now let's calculate it. dfxy by dx at x equal to 2, y equal to 3. I can calculate if fxy is x square, y square. It will bring a number, that number into x plus dfxy by dy, it will bring a number if x and y is 2 comma 3 into y. Whatever it comes, it will come as a function of x and y. That is the equation of tangential surface. Okay, but tangential surface can be 360 degree. With this formula, we have calculated tangential surface along a line that is connecting origin and 2 comma 3. What about a line that is connecting 2 comma 3 and 4 comma 5? Now you tell me. If I connect origin and 2 comma 3, generally people find this in the book. Can you tell me the equation of a surface? If I have a xy plane, on above xy plane I have a 3D surface. This is 3D surface. Now I have taken any point on xy plane at 2 comma 3. If I move up, it will hit 3D surface here. If it hits 3D surface here, at this point I can have tangential surface in many directions. Can you tell me a particular tangential surface which will be in direction of a line that is connecting 2 comma 3 and origin? Okay, that equation, if I try to find that equation of tangential surface, will be dfxy by dx into x plus dfxy by dy into y. This is what generally written in the book. Can you find the tangential surface equation at point 2 comma 3? Ready-made answer is dfxy by dx into x plus dfxy by dy into y, where dfxy by dx has to calculate it at 2 comma 3. dfxy by dy has to be calculated at 2 comma 3. Whatever is comes, net result will come as a function of x and y, and that will be equation of tangential surface at 2 comma 3. But along which direction? No one writes. That is along line connecting origin and 2 comma 3. Now my question is, can you tell me if there is a tangential surface all around 360 degree, which tangential surface equation, what will be tangential surface equation along a line 2 comma 3 and 4 comma 5? This is the assignment that anyone can take. Rather than by default line connecting origin and 2 comma 3, I want the tangential surface, because tangential surface is moving 360 degree. Which one tangential surface will belong to along a line on xy plane that will connect 2 comma 3 to 4 comma 5? I believe it is understandable. If I consider this is xy plane, this is origin, this point is 2 comma 3 and this point is 4 comma 4 comma 5. If I draw a line like this, then this is the line. Now above the 2 comma 3, I draw a vertical and then it is hitting the 3D surface, and that this is a 3D surface. At this point, and this 3D surface, if I draw a tangential surface, this tangential surface will be in 360 degree. I'm trying to find, or will have different equation. I am trying to find one particular tangential surface that will be in direction on xy plane from point 2 comma 3 to 4 comma 5. If I blindly calculate at 2 comma 3, blindly dfxy by dx at 2 comma 3, dfxy by dy at 2 comma 3, multiplied by x multiplied by y, by default, unknowingly, I'm trying to estimate the different tangential surface along the line that connect origin and 2 comma 3, but I want along a line between 2 comma 3 and 4 comma 5. Along that line, what will be the tangential surface? That I am asking, that people can think. If possible, then you can place the answer. Please don't mind supporting us. Plus 91 in the country code 9483160610 is the telephone number. Plus 91 is the India country code 9483160610 is the telephone number.